Today's objective is the student will be able to understand and apply the concepts of variation. So there are two types of variation that we will talk about, but this first one is called direct variation. Direct variation is a relationship between two variables in which one is a constant variable of the other. This means that when y increases, x also increases by the same amount. Another word for direct variation is proportional. Okay, so direct variation basically is just the relationship between x and y, and it's going to depend on a constant value k, which we will talk about. There is a formula for direct variation, and it's very simple. We will take a look at that as well as the notation for it. So like that little definition just said, it said direct variation is a relationship between two variables, x and y. The formula for direct variation, y equals k times x. K is going to be the constant variable that will increase x and y by the same amount. K is always going to be the same number. If k is 5, k is always going to be 5. If k is negative 50, k is always going to be negative 50 because k is a constant variable. Okay, so k is a constant variable, meaning that it can be any number, but once it is that number, it's that number. Okay, it doesn't change. The notation for direct variation is y varies directly with x. Okay, what this means in words is y varies directly with x. Okay, that's what this symbol means. So when you read something, when you read a problem, and it says y varies directly with x, or it gives you this symbol, what it means is this formula. These both mean that you need to use this formula, y equals k times x. When you see these two things, this immediately should be the formula that you go to. Okay? So we're going to look at some examples of direct variation. Oh, also really quick, since k is a constant value, we can find it by dividing the y by the x. That means that if we wanted to know what the value of k was, we can take our formula, y equals k times x, and solve for y by dividing both sides by x. Okay, these x's on this side will cancel out, and I'd be left with k equals y over x. Okay, that's how we would solve for k. Let's go ahead and look at some examples. So the example says y is directly proportional to x, and y equals 48 when x equals 8. Find the formula for y in terms of x. Okay, so the example wants us to find the formula. Well, let's look at what the example directions or claims were. It says y is directly proportional to x. That means we use the formula that we just talked about. Y is directly proportional to x. Okay? It says when y is 48 and x is 8. We'll use those in a second. So it says for what it wants here, find the formula for y in terms of x. Okay, basically what that means is it wants you to create a formula where y and x are the only two variables there. So we need to find out what k is and get a number there. To do that, we use the numbers that were given to us. Y equals 48 and x equals 8. We're going to plug those in. Okay, so what we're doing here is we're solving for k so that we can plug it in, so that we can have a formula for y in terms of x. We're going to solve for k by dividing both sides by 8, right? We're trying to get k by itself, so the 8's are going to cancel, and I have k equals 6. Now that I know that k equals 6, what I'm going to do is plug it in to this formula. And now what I have is a formula for y in terms of x. I don't have any other variables. This is what I have. I know that k is going to equal 6. Okay? This is the formula. We're going to be using this formula where k is 6 for the next 2 examples. Okay? So keep that in mind. Example 2 wants us to find the value of y when x is 2.5, right? So we just found the formula for y. Y is 6x. We just found that in the previous example, right? So now it wants me to find the value of y when x is 2.5. Okay, so we're going to plug in 2.5 for x. So now to solve for y, all I have to do is multiply 6 times 2.5, which is going to be 15. Next, we're going to look at trying to find the value of x, which is kind of opposite from finding the value of y. So again, we're still using that formula from the first example because we found the value for k, and we're still underneath that same set of directions. So we're still using that same formula that we found in example 1. Now it wants me to find the value of x when y is 120. We're going to solve for x by dividing both sides of the equation by 6. X is going to equal 20. Okay, so once you find out what your constant value is, it's very easy to solve for either x or y. It's not a hard concept. You're either going to multiply both sides by something if you're trying to solve for y, or you're going to divide both sides by something if you're trying to solve for x. Okay. This is going to be the last one we look at for this video. It says, which equation is not an example of direct variation and why? Okay, well, if you look at all of these choices, they all look very similar, right? We have over here, y equals something times x. Y equals something times x. Y equals something, even though it's a fraction, times x. The only one that's different is y equals something times x plus another number, right? So this one is not an example of direct variation, and not just because it looks different than the others, but because of this plus 1. You're adding another constant value. So adding another constant value. Okay, so this is different because it puts something extra to our formula. All of these other things follow this formula. Y equals k times x. Y equals k times x. Y equals k times x. They all follow the same format, every single one of those, except for this one. Because this would be y equals k times x plus something else. We'll call it, I don't know, p, right? This doesn't look the same as our original formula. That's why it's not an example of direct variation.